Welcome to today's explainer. If you grew up in the 90s, your idea of artificial intelligence probably looks a whole lot like the Terminator or the Matrix. But the reality we're living in today is actually far quieter and, honestly, incredibly powerful. Think about it. It's the YouTube algorithm serving you this very content, a bank automatically approving a mortgage, or a complex medical diagnostic tool. AI is literally running our daily lives in the background. But that silent operation brings up a massive, almost unbelievable issue that we absolutely need to talk about today.
It seems like a completely ridiculous question, right? Like, you'd naturally assume that the brilliant engineers writing the code for these cutting-edge systems know exactly how their creations are making decisions. But the shocking truth? In many of the most advanced systems today, they actually don't. And this right here is the core mystery of our explainer, the black box paradox. We have literally built systems so incredibly complex that the creators themselves often cannot fully explain how their own AI arrives at its conclusions. To understand how we kind of lost the map to our own creations, we have to look at how modern AI actually thinks.
Okay, let's dive into this. When you and I look up and see a bird, we immediately grasp the concept of a bird. But an artificial intelligence, it doesn't possess consciousness or comprehension. It doesn't actually know what a bird is. Instead, it processes what are called weightages. When developers build a program to identify something, they define unique features and assign a mathematical importance, a weightage, to each one of those features. So the AI is essentially just looking for an equation to solve. It's all just math.
To put that into perspective, let's look at a simplified breakdown of how an AI looks at our bird. The developers might program it to look for feathers, giving that a 30% weightage. Wings get another 30%, two legs get 20%, and a beak gets the final 20%. So, if we show the computer a picture of a crow, the AI scans the image, finds all four features, and the math adds up to a perfect 100%. The system confidently outputs, yes, this is a bird. It is incredibly fast and incredibly accurate, but there is a catch.
What happens when we showed this exact same system a picture of a penguin? Now, a penguin is absolutely a bird for sure, but it doesn't really have visible feathers, and its wings look a whole lot more like arms. Based on those original weightages we just talked about, the AI scans the penguin, only finds a beak and two legs, and hits a super low score of just 40%. And because of this low score, the AI confidently and entirely wrongly guesses that the penguin is not a bird. So how do we fix this? Well, we train it.
This exact training loop is the mechanism that eventually leads us straight into the black box paradox. Step 1. The AI guesses, and in this case it gets the penguin wrong. Step 2. A human steps in and corrects it, explicitly telling the program, hey, you made a mistake. And here is the absolute magic in Step 3. The AI is written in a way that allows it to automatically adjust its own internal weightages based on that feedback, so it lowers the importance of visible feathers and raises the importance of the beak. It tweaks its own internal parameters over and over again through thousands of corrections until it can accurately identify birds it has never even seen before.
Now, for decades, we simply didn't have the computer processing speed or the raw data to make this training loop work on a massive scale. But then came the absolute explosion of social media. Remember every time you uploaded a photo of your pet to Facebook and tagged it as a dog? You were actually providing automated, massive-scale training data. Millions of us every single day uploading photos and writing conversational captions provided the exact feedback loops AI needed to rapidly evolve. It learned slang, informal speech, and incredibly complex visual patterns completely automatically.
But, as you might guess, relying on massive automated training data comes with some pretty bizarre side effects. Let me share a fascinating real-world error with you. Researchers had a highly trained image recognition AI that was generally fantastic at identifying animals, but suddenly during testing, it began inexplicably failing. It repeatedly took photos of regular everyday dogs and confidently misclassified them as wolves. The developers were completely stumped. No way, right? Why would it do that?
Now, what's really interesting about this is it reveals the core paradox we mentioned right at the start. Because the training process involves the AI automatically adjusting millions of its own internal parameters and weightages over millions of cycles, the resulting code becomes entirely too complex for a human to just read and understand. You literally can't just open up the system and clearly see why it thinks a dog is a wolf. The developers know exactly what data went in, and they know what answer came out, but the decision-making process right there in the middle, it's become a complete mystery. It is a black box.
And this brilliantly illustrates the real danger of that black box. When researchers finally did a massive deep dive investigation to solve the wolf mystery, they discovered something stunning. In the massive data set used to train the AI, almost all the pictures of wolves just happened to have snow in the background.
So the AI, automatically adjusting its own weightages to find the easiest possible path to a correct answer, simply realized that snow was a 100% indicator of a wolf. It literally stopped looking at the animal entirely. If there was snow in the background of a photo, the AI just slapped a wolf label on it.
Okay, mistaking a dog for a wolf is a harmless, kind of funny quirk. But the stakes get incredibly high when this tech moves out of the lab and into the real world. A really famous example involved a major company using an AI system to analyze applications and shortlist candidates for job interviews. The result? The AI heavily discriminated against female candidates. When researchers finally managed to peek inside this black box, they realized exactly why. The training data was based on the company's past hiring decisions, and historically, they'd heavily favored men for that role. The AI simply noticed that pattern, gave being male a huge weightage, and just started filtering out women. See, the AI doesn't have an awareness of right and wrong. It doesn't hate women. It just ruthlessly follows the bias hidden in the historical data we feed it.
Everything we've talked about so far, from identifying wolves to generating text in something like ChatGPT, falls under the category of weak AI or narrow AI. It is highly specialized for one specific task. If you want a weak AI to do something totally new, you basically have to train a totally new program from scratch. But the future developers are chasing right now is general AI. This is a theoretical artificial intelligence that possesses broad, human-level capability, the ability to learn a variety of things, adapt to totally new situations, and reason through complex problems without needing to be completely retrained every single time.
If we map out the timeline of AI capability, we are sitting right at year 0 with weak AI. Experts predict that artificial general intelligence could be anywhere from 20 to 50 years away. But the true game changer sits even further down the line: artificial superintelligence. This is an intelligence that would surpass human beings in literally every possible way. Some speculate this could actually happen by the end of the century, though, to be fair, the timeline is purely theoretical at this point. The reason superintelligence is the focus of so much intense debate is because it triggers what is known as the technological singularity. Imagine an AI so incredibly smart that it can analyze its own code and design an even better, smarter version of itself. And then that new version designs an even smarter version. It becomes this unstoppable, exponential chain reaction of intelligence growth, completely free of any human input. This exact scenario is exactly why brilliant minds like the late Stephen Hawking and tech leaders like Elon Musk have publicly, loudly warned about the potential dangers of uncontrolled AI.
But hey, let's bring this back down to earth for a second, because there are plenty of experts who think these Hollywood-style fears are pretty premature. Even our most incredibly advanced AI today lacks any semblance of consciousness or self-awareness. Remember, it doesn't even know what a bird actually is. The desire to conquer, to seek power, or to destroy humanity, those are deeply, uniquely human traits. And AI is just a black box of complex math. The idea of it actively deciding to turn against us requires an inner self-awareness that is completely absent from the technology.
So, the absolutely crucial point is this: the danger isn't that the machine will wake up one day and hate us. The real danger is the black box paradox combined with human error. AI does not feel regret when it denies someone a loan unfairly or screens out a perfectly qualified job applicant. It simply follows the bias patterns we unintentionally taught it. The human responsibility here is massive. We must be the ones to monitor it, constantly correct its biases, and ensure its applications are fair. Furthermore, we really shouldn't fear AI taking our jobs directly, but rather realize that someone who learns to work with AI will inevitably outcompete someone who refuses to adapt.
We started this whole journey by manually feeding AI photos of birds and dogs just so it could learn basic patterns. But as these black box systems become more and more complex, as they dictate the content on our social media feeds and increasingly integrate into the very fabric of our society on the road to general intelligence, we have to ask ourselves, are we still just training the algorithm, or is the algorithm starting to train us? That is all for today's Explainer. Keep asking questions, and I will see you next time.